Hey everybody, it's Mr. Carr again. Today we're going to be looking at 6.3 day one. We're going to be evaluating a new thing called logarithms. Okay, so let's quickly talk about what is a logarithm. So one thing I want to kind of review is when we talk about inverse operations, we always use them to solve a given equation. So for example, if this is x plus 4, I would do the inverse of addition. So I'm doing the inverse of whatever operation there is there. So I would subtract 4 to both sides, and that would give me to x equals 8, like that. Okay, so again, because the problem is set up with addition, I would use subtraction. There we go. Subtraction to undo that. Since this is subtraction, I would use addition to undo that one. If this is multiplication, I would undo that with division. Since that's division, I would undo it with multiplication. X squared, something you've done in the past, you would square root to undo an x squared. To get rid of our cube root here, we would raise both sides to the third power. So we would do like an exponent to 3. That's our inverse idea. Well, our new idea is this one. How do we undo something like this? If I say 4 raised to some power is equal to 100, well, this is where logarithms come into play. This is my inverse here. So the inverse of exponential is a logarithm. That's our idea. Okay. So in this format, this is how our form is. So let's look at this one right here. So a logarithm is the inverse operation of an exponent. So even though it's just a word, not a symbol like addition or subtraction, it's actually still an operation. When you're taking the logarithm of something, you are doing an operation. Okay, and that's why if you plug something like this into your calculator, you'll get a number. Log, and sorry about that. Let me read this out here. When I put a little 2 here, this means log base 2 of 8 is 3. That's how I read that as a sentence. The exponential form of that is 2 to the third equals 8. So in a way, what I'm saying is, when I say log base 2, I'm saying 2 raised to what power gives me 8. So that's why the answer is 3 here, okay? 2 to the third power, 2 times 2 times 2, that's equal to 8. So that's our connection with logarithmic versus exponential form. So for example, so what I'm really saying is if I have b to the x power, okay, then that's the same as taking log base b, or sorry, I should say y equals b to the x power. That's the same as saying log base b of y is equal to x. Okay, so look at those positions. The exponent is right here with our logarithm. Our base is this base right here, and then this value that it equals, so b to the x, is in that spot right there. So I can do all the same things here with our exponential forms. Log base 4 of 1 equals 0. The exponential form of that is saying 4 to the 0 power is 1. Log base 12 of 144 is equal to 2. And the reason for that is because 12 to the second power is 144. Okay. Log base 1/4 of 64 is equal to a -3 because 1/4 to the -3rd power is equal to 64. That's the pattern that we're showing in each of these spots. Base right here, base right here, okay? These numbers are exponents like that, okay? And then these are the results right here, all right? And just as a quick reminder, the reason why this one, well, sorry, let me do this last one here. This one is log base 9. That's 9 to the third power equals 729. The reason why this one comes up to 64 is because 1/4 to the -3rd is the same as 4 to the +3, which is what equals 64 there. Okay? So let's do a couple of problems with that as well. We want to evaluate logarithms like this. The big question we want to ask ourselves is, if I say log base 4 of 64, that means 4 to what power is 64? So 4 raised to something gives me 64. Well, as we just saw on the previous slide, that's going to equal to 3, because 4 to the third power is 64. 2 raised to what power gives me 32? So a lot of these that are pretty straightforward, you can just kind of multiply it out real quick. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. There's 5. So that's why this comes out to 5. All right. With fractions like this, it's a little bit trickier, but it's still the same idea overall. 5 raised to some power is equal to 1/5. When I see that reciprocal, I'm going to start thinking about negative exponents because 5 to the negative 1 is the same as 1 over 5 to the 1. So that's why this equals a negative 1 here. Right here, 1/5 raised to some power is equal to 25. Same idea. If I have a fraction as my base, I want to turn it into a 25, like 25 over 1. That should be 1/5 to the negative 2 power because that would turn into 5 to the 2. Okay, so that means this is a negative 2 here. Log base 36, so 36 to some power is going to give me 6. Might be a little bit trickier to go this way, but remember, 36, if I take 36 raised to the 1/2 power, that's the same as taking the square root of 36. Well, that means that if 36 to the 1/2 power equals 6, this is equal to 1/2. All right. Now, all of these you can do in your calculator. So there's nothing wrong with using that, but I'm just going over these properties and how they work in terms of just how they evaluate and follow the definition of a logarithm. Okay. Special logarithms. In your calculator, you'll see a button that just says log on it a lot of the times. That is our common log. That is base 10 is what it's referring to. So anytime you see something like this, like if I say log of 100, that is saying 10 raised to what power gives me 100. So that's why if you take the log of 100, that equals 2. Okay. There's also another one called ln. That is the natural log. That uses a special number right here called e. So that's its own, kind of like pi. E represents one specific number, but it's going on forever as its own decimal, and it has no exact patterns to it. So it works a lot like pi in that sense. Okay, so for our purposes, I just want to focus on just making sure you can find these buttons here. So you want to evaluate it with the calculator. Just make sure you can try to find those logs. In a TI-84, you're going to hit math to get a bunch of these, but they should also show up on there. So I do log of 8. That gives me a 0.90 for my rounded off to 2 decimal places. And then when I do the natural log of 0.3, that comes out to a negative 1.20. Okay, so just make sure you can find that and do the same thing in your calculator. So this wind speeds S of a tornado as it travels d miles along the ground is given by this equation. So find the wind speed of a tornado that travels 220 miles. So it's traveling d miles. That means that d is equal to 220 here. So that's going to replace this. So the speed is going to be equal to 93 times log of 220 plus 65. Make sure you just plug this in your calculator correctly because this needs to be the log of 220. There's no additional trickiness to this one. It's just making sure you hit log of 220 in your calculator. So pretty much always it'll put it in parentheses. So if I do that for myself just to keep it separated, then do that. But if I just type in my calculator just like that, so it's 93, then log of 220, parentheses, and then plus 65, that comes out to a wind speed of about 282 point, let's go 2 decimal places, 85. And that's going to be miles per hour here. Okay. And that is it for today. That's our basic ideas of logarithms. We're going to keep going with some more types of examples with that, but that is it for this one. So make sure you are getting familiar with the calculator on that one and recognize how logarithms and exponentials are related to each other. All right. And that's it for today. So take care, everyone.